In the sulfur, how many allotropes can be formed? In the sulfur, there are three main allotropes can be formed. It will be rhombic, monoclinic and gamma sulfur. When both alpha and the beta forms which is become stable, hence it is known as transition temperature. Sulfuric acid we rated as H2SO4. If one oxygen which has been become less, it is known as what? Sulfurous acid. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called P block elements. Under that, we have discussed about the dioxygen preparation, physical and chemical properties of dioxygen, and also we have learned about the uses of oxygen. In addition to that, we also discussed about the oxides formation in the oxygen, and most importantly, the allotropes of the oxygen we also discussed, that is nothing but a ozone. In ozone, we have learned about the preparation, physical and chemical properties. Today, let us step up with the next topic of this unit by understanding the sulfur and its allotropes. And we are going to deal with the chemical properties of this sulfur and uses of sulfur dioxide also we are going to understand. And coming into the examination point of view, it is very much important to understand the manufacturing of sulfuric acid by contact processes. And we are going to discuss about the chemical properties of this sulfuric acid and their uses of sulfuric acid, OXOACIDS of sulfur, we are going to discuss in this session. So firstly, we will see what are the allotropes of sulfur. When it comes to the allotropes of the sulfur has three main allotropes. The first one is rhombic sulfur, which is known as alpha sulfur, which is known as what? Alpha sulfur. The second one is monoclinic sulfur, which is known as beta sulfur, and the last one is gamma sulfur. So, in the sulfur, how many allotropes can be formed? In the sulfur, there are three main allotropes can be formed. It will be rhombic, monoclinic and gamma sulfur. So, we will discuss one by one in detail. First, I will go with the rhombic sulfur. When it comes to the rhombic sulfur, so this is the most common allotropes of the sulfur and it is stable up to 95.6 degrees Celsius. And it is usually prepared by taking the solution of rolling sulfur with carbon disulfide and they will start evaporating. When the solution is started evaporating, the yellow crystals will be formed. That yellow crystal which is known as what? Rhombic sulfur. And this rhombic sulfur which is insoluble in water but soluble in some of the organic solvents like benzene, ether, etc. But it will be readily soluble in carbon disulfide. It has the melting point around 112.8 degree and it has specific gravity around 2.06. Okay, and this crystals of rhombic sulfur which consists of 8 sulfur atom which is there in the rhombic structure and it gives rise to the rhombic shape to the allotropes of this alpha form. Okay, so how many molecules will be there? There are 8 atoms that constitute the rhombic shapes to the alpha form of the sulfur. Okay, coming into the monoclinic form or the monoclinic sulfur. This form of sulfur will be stable up to 95.6 degrees Celsius and usually it is prepared by melting the rhombic sulfur in a dish and allowing it to cool till a crust which is formed at the surface. The two holes which is also made in the crust and remaining liquid is poured out. On removing the crust, the colorless needle-like crystals of monoclinic sulfur will become visible. What does it mean? So, how we can prepare the monoclinic sulfur? It is usually prepared by considering the heating process of rhombic sulfur. So, they'll take the rhombic sulfur in a dish and they started evaporating. When they started evaporating, almost all the water molecules will be completely get evaporated and finally it give a crust. When they obtained the crust, they made a hole in that dish to remove the remaining water impurities or any impurities which is there, which is allowed to pour it off. Later, we obtain the needle-like crystals, that is nothing but a monoclinic sulfur or beta sulfur. It has the melting point of 120 degrees Celsius and specific gravity of 1.96, and it is again soluble in carbon disulfide, and the crystals which also consists of S8 ring, but it is made up of, but the mode of packing of these rings are different from the rhombic sulfur, and the packing in this case will lead into the monoclinic crystals. Here also we can expect 8 sulfur atoms which are constitute the monoclinic structure to the beta form of the sulfur. Hope you all understood with the alpha and the beta form. So you can see that this is a structure of S8 molecule. Both rhombic and monoclinic sulfur has S8 molecule packed in a different manner to give a different crystal structure. The S8 in both of this form will be packed to give a crown shape. You can see that in the first structure, there are 1, 2, 3, 4, 5, 6, 7, 8. So, 8, yes, that is nothing but the 8 sulfur atom, or you can say molecules also. They constitute to give a crown shape to the rhombic sulfur. And alpha form of the sulfur is stable up to 95.6 degree and changes to beta sulfur above this temperature and vice versa. Or you can write that alpha sulfur can changes into beta sulfur about 95.6 degree. Similarly, vice versa, that is from 95 to 96 degree. So, if you are taking the alpha sulfur and if you started evaporating, you will get a beta form. Similarly, if you take the beta form and started heating, you will get a alpha form. So, this is a reversible reaction. Okay, and you can see this reaction in this manner also. And at 369 Kelvin, it forms a stable structure, and at this temperature, when both alpha and beta forms which has become stable, hence it is known as transition temperature. What we call for that temperature? We call it as a transition temperature. Another allotropes of the sulfur, that is cyclo S6 ring, adopts a chair form, and S2 forms are also formed at very high temperature, and it is paramagnetic because of the 2 unpaired electrons which are present in anti-bonding pi star orbitals of oxygen atom. You can see that. So, one is crown shape and one is chair form. Okay, or you can write like this also. So, one is chair and one is crown form. Okay, coming into their preparation of sulfur dioxide. Okay, we will see how we can prepare the sulfur dioxide, which are the compounds of sulfur. Okay, the sulfur dioxide is formed together with a little sulfur trioxide when sulfur is burned with air in the oxygen. You can see that the sulfur, which is upon heating with the oxygen which is there in the air, you will get a sulfur dioxide. Okay. In laboratory method, we can also prepare this sulfur dioxide by readily treating with the sulfide with dilute sulfuric acid. These are the sulfide, okay, which is nothing but an aqueous solution which is allowed to react with the sulfuric acid. I have represented in the form of H plus to give a sulfur dioxide and water molecule. This is a laboratory method of preparation of what? Sulfur dioxide, which are the compounds of sulfur. Coming into the industrially, how we can prepare this sulfur dioxide? Industrially, it is produced by the byproduct of roasting the sulfide ores and the gas which is formed after that, which is drying and it is liquefied under the pressure and stored in the steel cylinders. Okay. So, it is a iron sulfide which is allowed to react with the oxygen to give a iron oxide with the formation of sulfur dioxide. This is how the compounds of sulfur, that is sulfur dioxide, will be prepared by using different methods. Next, we have the chemical properties of this sulfur dioxide. Sulfur dioxide, when it is passed over the water, it forms what? Sulphurous acid. We know that sulfuric acid is H2SO4 and one oxygen if you reduce, it becomes what? Sulphurous acid. It becomes what? Sulphurous acid. Okay. So, how we can prepare the sulphurous acid? Simply by passing the water to the sulfur dioxide, which is a gas, to get a sulphurous acid. And with the alkali, it forms two series of salts. What does it form? Suppose, if you take the sulfur dioxide, if you treat with very strong alkali, it forms what? Sodium bisulfide will be formed. Similarly, suppose if you carried out the same reaction by considering two molecules of alkali, then along with the water molecule, you can expect the sodium sulfide. This indicates that even though the sulfur dioxide can react with the alkali, if you increase the number of alkali, the product formations will be different. Okay, and it forms the different salts. The reaction with halogen, how does it react? It readily combines with the halogen to form a sulfuryl halides. What does it form? It forms a sulfuryl halides. So, here I have a sulfur dioxide which is allowed to treat with the halides such as chloride. You can take fluoride, bromide, iodide, and I have used a chloride here. Okay, in presence of charcoal as a catalyst, it forms what? Sulfuryl chloride, which is nothing but a sulfuryl halide. Okay, you can see that sulfuryl chloride. Coming into the reducing nature, how does it act as very good reducing agent? Sulfur dioxide will understand now. Okay, the most of the sulfur oxide and its aqueous solution behaves as a reducing agent and it reduces the ferric salts to the ferrous salts and decolorizes the potassium permanganate solution and turns the acidified potassium solution into green. So here I have a two reaction to say that my sulfur dioxide is also acting like what? Reducing agent. You can see that if you take the ferric sulfate, which is allowed to treat with sulfur dioxide in presence of water, what does it forms? It converted into ferrous sulfate, where in this case iron will be in the +3 oxidation state, whereas iron here in the ferrous sulfate which is exhibit in +2 oxidation state. You can see that the oxidation state of the iron which has been reduced from +3 to +2. Hence, it is acting like a reducing agent. And you have one more reaction, that is, if you take a potassium permanganate, that is a dark violet color crystals, hope you know that. If it is allowed to treat it with a sulfur dioxide and water molecule, it forms a potassium sulfate and manganese sulfate, and also it forms a sulphuric acid, that is H2SO4. It decolorizes the dark pink color of this potassium permanganate and it has become what? Green color, or sometimes you can say that it become colorless also. This indicates that even though in the potassium permanganate as well as in the ferric sulfate, it acting like a very good reducing agent. I can replace these two reactions in this way also. Okay. Coming into the structure of this sulfur dioxide, we know that this sulfur dioxide can exhibit in a two form. Okay. And these two canonical forms as one sulfur atom and which consists of two oxygen atom, and where between the oxygen as well as with the sulfur we have a double bond, and suppose if the double bond which has been shift and it gives us to the two canonical forms of the sulfur. So these are the two resonating forms of the sulfur dioxide. Coming into their uses, we all know that sulfur dioxide, it has very wide range of uses, right? So in the refining of petrol and sugar, we will use this sulfur dioxide, and also we are using in the bleaching of wool and in the silk. We use this sulfur dioxide as a disinfectant and as in the preservative, as a drying agent for the gases, in the manufacturing of sulphuric acid in many chemicals, and the liquid SO2 is also used as a solvent for many organic and inorganic chemicals. These are the uses of what? Sulfur dioxide. So, hope you have understood with the allotropes of the sulfur and the compounds of sulfur. We'll move towards the manufacturing of the sulphuric acid by contact process, and it is very important for the examination point of view. Especially for the 3 marks, they are going to ask from this unit to write the manufacturing of ammonia by Haber's process, or to write the manufacturing of nitric acid by Ostwald process, or you can expect manufacturing of sulphuric acid by contact process. All these 3 questions are most expected one from the P block elements. So, we will see how to write the manufacturing process to get a 3 out of 3. Okay. So, the steps will be involved. There are 4 steps will be there. Okay. In the examination, sometimes they will ask you to write the optimum conditions which is required for this reaction also. You must be very careful with the optimum conditions where we are using in the particular step. Okay. In the first step, we are taking the sulfur which is allowed to burn with oxygen to give a sulfur dioxide. We are taking sulfur which is allowed to treat with the oxygen or allowed to burn with oxygen to form a sulfur dioxide. That is the first step. In the second step, the sulfur dioxide will be further oxidized to give a sulfur trioxide in presence of air. So, here you can take that again the sulfur dioxide which is allowed to react with oxygen in presence of vanadium pentoxide as a catalyst at 2 bar pressure and 720 as a Kelvin, that is a temperature, you will get the sulfur trioxide. And during this process, the delta H values is minus 196.6 kilojoules per mole. So, what are the optimum conditions we are using here? We are using the temperature around 720 and the catalyst is vanadium pentoxide, and we are using the pressure around 2 bar. In the second step, to further oxidize the sulfur dioxide into sulfur trioxide. In the third step, we are doing the adsorption process where the sulfur trioxide, which is allowed to treat with the sulfuric acid, which is freshly prepared to give a oleum. How to remember this oleum formula? You can see that there are H2, S2 and O4 and O4 and O3, which is nothing but a O7. So it is H2, S2, O7. That is oleum. In the first step, the oleum, which is further treated with the water to get a 98% pure sulfuric acid. Okay. In the examination, all the 4 steps with a balanced reaction, you have to write to get a 3 out of 3 from this part. Okay. So, hope you all understood. In the first step, what you have to say? In the first step, the burning of sulfur with the oxygen to get a sulfur dioxide. In the second step, sulfur dioxide will be further oxidized to get a sulfur trioxide in presence of vanadium pentoxide as a catalyst and a pressure of 2 bar and a temperature around 720 Kelvin. In the third step, where the sulfur trioxide, which is get absorbed with a pure freshly prepared sulfuric acid to give a oleum. In the first step, the oleum will be treated with the water to give a pure sulfuric acid. So, you can understand this process by looking at this diagram. So, we will understand how industrially they'll prepare the sulfuric acid with the following chamber. Okay. So, first what they'll take the sulfur and they allow to treat with the A. These are the sulfur which is allowed to treat with the A, and this will be done in the sulfur burner. Okay. So, what will happen? We know that sulfur combines with the oxygen to form a sulfur dioxide. So, what does it form? It forms a sulfur dioxide. This will be passed to the dust precipitator. This is a dust precipitator where again this sulfur dioxide, which is further oxidized with the oxygen, so that if any impurities which is there will be just precipitate in the dust precipitator. Later, this sulfur trioxide, okay, sulfur trioxide will be passed to the washing and cooling tower. It will be passed to the washing and cooling tower where the water will be sprinkled at the top. So, what will happen? If any impurities which is there, it will be washed away and this will be passed to the another separate chamber where they'll pass to the another separate chamber where they are going to dry this sulfur trioxide. Okay. So, they'll spray the concentrated sulfuric acid here. Why they will spray? Even though we are preparing the sulfuric acid, how does they will spray the concentrated sulfuric acid and why they are spraying? Because here, if any water content which is there, because already we have sprayed the water to the sulfur trioxide, if any water content which is there, it has to be removed, right? So, that is why they'll use a concentrated sulfuric acid here, so that it is acting like a very good strong reducing agent. It removes out the water, so that the dry SO2 and oxygen will be again formed and it will be passed through the arsenic purifier chamber. Because whatever the product we prepare, it should be removed from the arsenic. It should be free from arsenic. It is very poisonous, right? So, that is why again to check it once again, they'll pass through the arsenic purifier and they'll see that if any poisonous impurities which is there, it will be removed out. And finally, it has to be preheated and it will be passed through the preheater chamber. After preheated, this sulfur trioxide will be passed to the dry sulfur dioxide with the oxygen. It will be passed to the catalytic chamber where the vanadium pentoxide which has been used. Okay, and they are maintaining the pressure around 2 bar and the temperature around 720 Kelvin. So what does it happen? The sulfur dioxide react with the oxygen and forms a sulfur trioxide. This sulfur trioxide will be again sprinkled with a concentrated sulfuric acid to get a oleum. Once we got a oleum, again it has to be dissolved in water to get a concentrated sulfuric acid. This is how they'll prepare the sulfuric acid by this contact process. Hope you all understood. But here you can observe here, even though you are taking the sulfur dioxide here, you have added a concentrated sulfuric acid. So you are asking me that why the reactions will not taking place with the dry sulfur dioxide with the concentrated sulfuric acid? No, because whatever the reaction condition has to be maintained, we are not maintaining at this point, so that the reactions between the concentrated sulfuric acid with the sulfur dioxide will not be happened. So that is why it has to be sprinkled with concentrated sulfuric acid and to remove the water content which is there in the sulfur dioxide. So hope you all understood with this method. Same way I have put the points here. In the contact process, sulfur dioxide will be produced by burning with the sulfur or with the iron pyrites in the furnace, which is known as what? Sulfur burner, and the dust particles will be removed by spraying of water and the gaseous mixtures will be obtained, that is SO2 and O2. Later it will be cooled in the coolers and it will be dried by spraying with the concentrated ester SO4 in a dryer, and impurities like arsenic has to be removed by arsenic purifier, which contains a gelatinous hydrated ferric hydrate. You can see here this arsenic chamber will be consists of gelatinous hydrated ferric oxide. It removes the arsenic content which is there if it is there in our compounds. Okay. Then the mixture which has been heated up to 400 degrees Celsius and it has been preheated and sent to the contact tower which is containing the catalyst. Here the SO2 is oxidized to SO3 in presence of vanadium pentoxide as a catalyst, and the heat will be released too much. And one more thing, during this process, you would have asked me that why this sulfur trioxide is again treating with sulfuric acids. That is mainly because during this process, if you add the water to the sulfur trioxide, again is an exothermic reaction, lot of heat will be liberated. In the industry, if they are preparing this concentrated sulfuric acid, it's not so easy to maintain that so much of heat. That is why first they'll spray the concentrated sulfuric acid, later to form a oleum. Later that oleum will be dissolved in water to get a sulfuric acid. The sulfur trioxide which is formed in a catalytic chamber converter which is absorbed by the concentrated sulfuric acid in the adsorption tower to get a oleum, and the oleum will be diluted to water to get a sulfuric acid. This is how they'll prepare the sulfuric acid by contact processes. Next we have the chemical properties of this sulfuric acids. Okay, first we will go with the acidic property, and coming into the sulfuric acid, usually it is acting like a strong dibasic acids, and in the aqueous solution it will be ionizes in the 2-step. So in the first step you can see that H2SO4 reacting with the water, that is treating with the water molecule, so it can give rise to it can accept one more H plus ions and forms a H3O plus ion, that is a hydronium ion, and you can see that the H2SO4 is giving rise to one H hydrogen ion, hence it forms a HSO4 minus. Similarly, that HSO4 minus, again if you treat with the water, it can loses one more hydrogen atom and become SO4 2 minus. This reactions which indicates that it can readily undergo ionization process where it can easily give rise to the H plus ion. Hence it is known as what? Dibasic acid which give rise to the 2 H plus ions. Hence it is known as what? Dibasic acids. Greater the values of Ka1, which means that it mainly ionizes the H plus ions from HSO4 minus, and higher the values of dissociation constant show that it is a strong acids. And it forms a series of salts, that is bisulfide and sulfide, as well as it decomposes a carbonate and bicarbonate with the evolution of carbon dioxide. And it can also acting like a strong oxidizing agent because it oxidizes the metals as well as the non-metal and get reduces to sulfur dioxide. You can see that the copper is a metal which is allowed to react with a concentrated H2SO4. It will replaces the hydrogen from the sulfur, hydrogen from the sulfate to form a copper sulfate with a SO2 formation, that is sulfur dioxide. Similarly, it can react with the non-metals like sulfur and carbon to give rise to the sulfur dioxide, water, carbon dioxide and water molecule. This indicates that it acting like a very good oxidizing agent and it can reduces to SO2. So, H2SO4 can reduce back to SO2, that is sulfur dioxide. And you can see that if you take the sugar, okay, so even though that sugar, if you are treated with the sulfuric acid, it removes the 11 water molecules and gives us to the carbon. Okay, so it is a dehydrating agent and concentrated sulfuric acid due to the great affinity with the water acting like a powerful dehydrating agent. Hence, it is used for drying of gases and it removes the water from the organic compound, where you can see with this example. Coming into their last reaction with the halides, okay, it displaces the volatile acids from their salts. So, this is a metal halide which is allowed to react with the sulfuric acid. So, it replaces the metal. So, it forms a hydrogen halide with a metal sulfate. Here, the M stand for metal and X stand for halide. You can take with the example of sodium chloride, which is nothing but a metal halides. Okay. So, NaCl, which is allowed to react with H2SO4, what does it forms? Na will be combined with SO2 to form a Na2SO4 and the Cl combines with the H and forms a HCl. This is how it can react with the halogen to give a respective salts. Coming into their uses, okay, where exactly we are using the sulfuric acids. For the manufacturing of fertilizers such as ammonium sulfate and superphosphate of lime, we use a sulfuric acids, and in the manufacturing of acids like HCl, HNO3, etc. In the manufacturing of explosives like picric acid, TNT, and in the nitroglycine as well as with the trinitrotoluene, we use this concentrated sulfuric acid. And in the petroleum refining, in the manufacturing of dyes, drugs, and in the disinfectant. Not only on this, we can use this sulfuric acid in the textile industry, leather industry, as well as in the detergent industry. You would see that in the storage batteries also we use this sulfuric acids, and for cleaning of metals before the electroplating, galvanizing, as well as in the enameling, we use the sulfuric acid, and very importantly, we use the sulfuric acid as a laboratory reagent. Coming into the oxoacids, we have very few oxoacids of sulfuric acid. The first one is sulphurous acid. Already I have explained that sulfuric acid we rated as H2SO4. If one oxygen which has been become less, it is known as what? Sulphurous acid. You can see that we have sulfur atom. Between the sulfur and oxygen atom, we have a double bond and we have a 2 lone pair of electron and we have a 2 OH. And coming into the another sulphurous acids, okay, in this form you can see that the sulfur has 2 double bonds with a 2 oxygen atom and thereby it forms a single bond with the OH. We have one more compound that is known as oleum. It is also known as what? Pyrosulfuric acid. Here also there must be a sulfur atom and between the 2 oxygen atom there must be a double bond. Another one speciality is between these two, we can expect one bridge like structure with the oxygen. And coming into the last one, that is pyroxodisulfuric acid. Here also you can see that between the two sulfur atom, we have two oxygen atom which is acting like a bridge. These are the oxoacids of sulfuric acids. In the next class, we are going to discuss with a group 17 elements. Okay, so by this I like to say that what are all the things which I covered in this session, which is very important for the examination point of view, especially the manufacturing of sulfuric acid by contact process. It is very important. Have a look on it, try to write the points and write it on your examination. We'll meet you with the next session. Till then, take care, be safe. Thank you.